Breaking AI shift today. DeepSeek will train some of its models on Huawei chips. This is not a routine component swap. It is a strategic capacity move that can change timelines, prices, and who ships first. If DeepSeek can reliably train on Huawei, do release dates stop being decided by Nvidia queues? How soon could that flip happen? Which model tiers move first, and what does it do to cost and cadence? Keep those questions in mind because we will answer them before the outro. If you build, invest, or create with AI, this breakdown turns a headline into a practical playbook you can use today. 1. Why a second lane now? Pressure you can feel. Why would a leading lab open a second lane for training now? For more than a year, demand for training-grade accelerators has run hot. Ambitious pre-training cycles collide with long booking windows, shifting allocations, and hyperscalers that can preempt supply. A single missed slot nudges a deliverable into the next quarter, quietly raising cost and crushing momentum. Leaders triage scope, engineers juggle schedules, and go-to-market plans lose credibility. That hidden pressure is the context behind DeepSeek routing some training to Huawei's Ascend platform. It is not a wholesale migration. It is targeted diversification, so work starts when the team is ready, not when a calendar slot opens. Think of the roadmap like a portfolio. At the top sit frontier-scale experiments that stretch context windows, routing, and memory to the limit. Those runs still belong on the fastest, most proven stack a team can access with confidence. Beneath that are mid-size pre-trains, instruction tunes, safety refreshes, domain adaptations, and distillation cycles. Do those really need the absolute ceiling on synthetic benchmarks, or do they need reliable starts and tight iteration? Which produces more value for customers? Theoretical peak flops or the ability to ship on the promised date? A second lane makes those loops possible when the top lane is saturated. There is also the regional layer. Building a domestic compute stack lowers import friction, increases compliance comfort, and creates pools of capacity insulated from cross-border shocks. When a credible cluster exists and the toolchain reaches baseline maturity, routing a subset of workloads becomes rational. Teams gain scheduling flexibility, finance gains cost certainty, and leadership gains resilience against policy changes that ripple through global supply. None of this abandons the incumbent leader. It simply adds a workable alternative so the entire roadmap is not stuck in a single line. Timing matters. Capability growth is rarely one heroic leap. It is the compounding effect of many runs that start on time. A second lane turns blocked weeks into learning weeks, and learning weeks into shipping weeks. In a market where users expect visible progress every quarter, is there any advantage more valuable than dependable cadence? That is the quiet value behind this headline. 2. Inside the stack. What must be true? Cross-vendor training only works when the whole stack lines up. First comes software maturity. Nvidia's CUDA world is famous for breadth and polish, kernels, collectives, and libraries that cover common paths and many edge cases. An alternative lane must map high-level frameworks like PyTorch to its operators with enough coverage, stability, and performance to make production work sensible. This is not about day-one parity. It is about confidence that the jobs you choose will converge on time and meet quality targets. Selective adoption is the right approach. Start with workloads whose computational profile and stability are well understood. Expand as results confirm expectations. Next is interconnect and topology. Distributed training lives or dies on communication. All reduce overhead, pipeline bubbles, and imbalance can erase headline flops. A viable lane keeps accelerators busy at realistic batch sizes and sequence lengths, not just in tiny benchmarks. Teams test with production batch regimes, measure tokens per second, and look for smooth scaling as nodes increase. Industry queues can stretch to weeks at peak, and tokens per second can swing meaningfully with sequence length and interconnect efficiency. Treat those as illustrative ranges. The real numbers depend on topology and tuning, but the direction of travel is clear. Then comes numeric precision and optimizer stability. Modern large-scale runs lean on mixed precision, often FP8 for activations and gradients with careful scaling. Kernels must avoid NANs, optimizers must remain well-behaved, and loss curves should track reference runs. Engineers validate on known datasets, compare perplexity and downstream scores, and check that convergence time does not drift outside budget. Would you ship if accuracy sits inside your tolerance bands and training time stays inside the window? Most leaders would. Reliability across time matters just as much. Long jobs need clean checkpoints, quick restarts, and predictable memory behavior. If a glitch hits at hour 90, do you recover in minutes or lose a day? Repeatable recovery is what lets managers set dates and keep them. Finally, developer experience decides whether adoption spreads. If the toolchain installs cleanly, logs are decipherable, and documentation shows reproducible examples, engineers will persist. DeepSeek placing real workloads on an alternative lane increases pressure on compilers and libraries to improve, which benefits the entire community. The information August 29, 2025 confirms DeepSeek will train some models on Huawei chips. Bloomberg, August 29, 2025 frames Huawei's profit return with domestic AI momentum. Tokens per second vary with sequence length and fabric efficiency. Queue windows can run days to weeks at peak. Illustrative ranges to guide planning. 3. From queue to cadence. 4 shippable scenarios. Scenario 1. A 30 billion parameter instruction model for customer support. The technical goal is helpful multi-turn dialogue with retrieval awareness and strong safety. The business goal is a non-negotiable launch date. The primary cluster is booked for weeks. A second lane with immediate availability lets the team start now, run internal evaluations, and hit parity with reference targets. Should a customer wait for a marginally faster cluster or ship on time with equivalent quality? The answer decides revenue, not just benchmarks. Scenario 2. A weekly refresh pipeline for a distilled assistant. The team curates fresh data, monitors drift, and retrains every Friday. Peak throughput matters less than predictability. The second lane becomes a standing booking. Training starts Tuesday, tests run Thursday, update ships Friday. If a rival waits for capacity, can they match your rhythm even with slightly faster hardware? Not if momentum is what users notice. Scenario 3. An enterprise search vendor trains a domain model to understand internal jargon and retrieval patterns. They combine language modeling with contrastive objectives and evaluate against realistic tasks. If the alternative stack supports that mix reliably, the vendor finishes on schedule and deploys across a mixed fleet that satisfies regional policy. What matters to the buyer? Peak flops or a system that is fast enough, accurate, and compliant? The purchase order answers that question. Scenario 4. A video generation research team needs a capable base before tackling motion control and editing features. The plan is staged. Run early epics on the second lane to save time and budget. Move final convergence to the fastest lane only if the last few points of quality truly matter. That phased approach balances cost and output without stalling the roadmap. Actionable today. 4 quick steps for builders. Start a pilot on a second lane with a known architecture. Build a compatibility matrix of ops you depend on. Test FP8 stability on your real data with your production batch regime. Track checkpoint recovery time and failure modes across a week-long run. If this map saved you a week, tap like so more builders see it. If this mapping clarified your roadmap, like this video and comment with the one workload you would move first, and why. 4. What smart money and builders are saying. Hardware analysts frame this as concentration risk management. When one supplier holds your training plan, pricing and scheduling power sit with that supplier. The moment an alternative proves viable for real work, negotiations change. Buyers blend strategies, suppliers sharpen offers, and cost curves smooth because no single bottleneck can freeze the roadmap. Policy watchers see a regional strategy maturing. Training inside a domestic compute stack reduces friction around data movement, improves compliance assurance, and supports control over deployment cadence. It also spreads capability, which can raise the global pace of progress if evaluation norms and safety practices keep up. More lanes do not guarantee quality, but they increase the number of serious experiments that reach production. Volume creates learning. Learning produces better models and better safeguards. Practitioners focus on developer experience. Adoption rises when the alternative feels familiar. If PyTorch code runs with minimal edits, operators are covered, and debugging is not guesswork, curiosity turns into pilots and pilots into production. DeepSeek's move pressures the alternative toolchain to reach that bar because real tickets from real workloads drive clear priorities. Documentation gets better. Examples become honest. Kernels that looked fine in isolation are tuned for the messy realities of week-long runs. Investors convert these dynamics into resilience and margins. Blended compute strategies reduce exposure to single points of failure and soften the shock of sudden price moves. Vendors who deliver during tight markets earn reputation that compounds into renewal and expansion. Training diversification is margin insurance disguised as scheduling flexibility. Time to close our open loops. How slow can a lane be and still win the product race? If a lane is roughly 10% slower but starts today, it can beat a lane that starts 6 weeks from now because the calendar, not the clock speed, decides who ships. What risk will a top lab tolerate before shipping? A practical rule holds. If PyTorch code runs without a rewrite, error logs make sense, and recovery is fast, the lane is ready for real work. 5 signals to watch how the map could tilt. In the near term, what early signals should you trust? Talks, model cards, and recruiting posts often disclose enough to infer throughput, convergence behavior, and stability for specific sizes and context windows. A few numbers paired with candid caveats invite other teams to try. If several independent groups complete credible runs, a flywheel begins. More users test the lane, more issues are filed, and fixes land faster because they are driven by production pressure. Expect rapid compiler and library updates that target practical bottlenecks, operator coverage for attention and routing, tighter memory planners, and more efficient collectives. 2-phase and 3-phase training plans will normalize. Early epochs will run where capacity is abundant. Final convergence will happen where maximum quality can be extracted. Orchestration will catch up, making checkpoint transfer, metric continuity, and mixed hardware monitoring routine. Teams that master this choreography will train more often without exploding cost, because compute becomes a portfolio to manage, not a single constraint to accept. Around the lane, partners will appear. Cloud providers will publish templates that launch jobs with sensible defaults. MLOps vendors will bake in evaluations, dashboards, and artifact export for mixed deployments. That scaffolding lowers activation energy for cautious teams and converts interest into pilots that either succeed quickly or fail informatively. Longer term, expect multi-vendor clusters that route submodules to different accelerator families based on price, memory, and latency. Portable training layers will improve until scripts feel close to hardware neutral. If that happens, competition will pivot toward data curation quality, evaluation discipline, tool use reliability, and safety alignment under stress. The stack will still matter, but craft will dominate. For teams that invest in engineering excellence, that is good news. One lab opening a second training lane will not end an era. It will change the tempo of useful work. DeepSeek's decision turns capacity scarcity into a scheduling strategy and reframes compute as a portfolio you manage instead of a queue you endure. If more teams follow, the center of gravity shifts from waiting for access to choosing the right lane for each job, then moving on to the next improvement. 2 engines beat 1, especially when the calendar decides who ships. Next, we will break down early throughput signals and what they imply for cost per model, time to quality, and release cadence. Subscribe for the benchmark breakdowns next, and add your roadmap questions so the next analysis targets what you need most.